So what we're going to do this morning is we're going to learn, not learn because you guys learned before. We will relearn the bottom part of page 172, which is about induced charges. And I'll also talk about how to detect charge. So, you know, this diagram, because I don't have the soft copy, so I'm just going to sketch it out. So, you know, the diagram where somebody brings the charge rod and put the finger there, you know that diagram, right? Do you understand what's going on? My thing is blocking. Because it's this kind of question they always ask, you know, in IGCSE, where they have the sphere, right? And then the sphere is placed on top of an insulated holder. Then this is someone bringing the charge rod nearby. And then the second diagram, I know got the finger there and all that. So do you understand what's going on? Like what's happening with the, with you know what's happening over here? What was this explained to you? No. Don't know. Because I'm asking because this question, this kind of question always comes up for IGCSE. So if you don't know what's going on, definitely people ask you to explain. You don't know what's going on, how to explain lah. Right? Because the thing is, in your book also they don't say what happens. They just tell you, oh, the metal sphere is being charged. The sphere ends up with opposite charge. They don't tell you what's happening. They just tell you what happened. Like, and the last part, the rod is charged, and you're like, oh, what's going on? So I'm going to put some notes here in this. I mean, I'm going to write down some extra information here on the slide, so you can copy down if you need, you know, like in your book or you on your sticky note, you stick in your textbook. Because this is like I said, this kind of question always comes up in IGCSE, so you do need to know what's going on. The purpose of this diagram is to charge the rod. So I'm going to write that out here. Purpose is to charge the, not rod, sorry, to charge the sphere. What I mean by the purpose is to charge the sphere means this sphere, we want to make it become positive, or we want to make it become negative. So that means, because like under normal circumstance, don't care about this charge rod first, we put one side, okay? This sphere, say for example, is a metal sphere. Yeah, it has to be, not example, it must be a metal sphere. So this metal sphere, you must remember metal is a very good conductor. All right, it's a very good conductor. So the electrons are free to move, very easy to move on the surface. Okay, so let's recall again just a little bit from earlier revision. All atoms, right, we know got positive and negative subatomic particles, right? There's neutrons also, but we'll focus on positive and negative. So positive is proton, negative is electron. Now remember that proton sits in the center, it cannot come out. It's very, very difficult to come out. So just think of it as cannot come out. Electrons are on the outside, so they can go out. Right, like this is the house, people all locked inside the house, cannot come out. Then you have the dogs outside running, then these dogs can run out lah. They can run out, some extra dogs can come in, that one is chemistry, that one don't need to bother. Physics, we just look, electrons can go out. It is the unbalanced number of protons and electrons that makes the whole thing whether got charge or not. If they are balanced, then it's neutral. If it's not balanced, then the atom becomes an ion, it becomes a charge. So only electrons can move. So you must remember, proton cannot move, positive cannot move, only the electron can move. Not even negative, don't even say negative, say electron can move. But not wrong lah, if you say negative charge can move, because memang electron is negative. Okay lah, I'll put it this way, negative or electron can move. Okay, so remember that for metals, In the metals, right, the electrons are all free to move. The moment it's a metal, you find the electrons are always moving on the surface. That's why metals are very good electrical and heat conductors. Insulators, the electrons cannot move easily. When you take the wool cloth and you rub, you can remove the electron from the surface. That means the wool cloth push the electrons. Where it push the electron go to, the electron stuck there. Like if you rub, the electron move to the plastic become negative. If the wool rub until the electron go to the wool, then the wool cloth become negative and it's stuck there. It doesn't move. That's why static electricity refers to this kind of charges. Once you push there, it's stuck there. It cannot move. Metals, electrons can move easily, right? You try to push the electron can come back easily. It moves very, very fast. Cannot force it to go somewhere and make it stay there. Very hard. Stay there, a bit difficult lah. Because metal is, the electrons are free to move. Okay. So why am I mentioning this? Because in the bottom part here of this induced charges, like I said, this part is the one where normally comes up in IGCSE in the IGCSE exam. The purpose is to charge the metal sphere, and metal, we know the electrons are free to move. So you must think of it as, okay, all over the place, the electrons are free to move, but they are, at the moment, is neutral lah. And then the bottom part here, this is, the metal sphere is sitting on top of an insulated stand. That means the electrons cannot go through this insulated stand. Okay, so this maybe you can think of it as just like plastic or like wood lah. The electron cannot go through. Okay, so these are insulators. Okay, these are insulators. Okay, so in order to charge the metal sphere, how to do it depends on whether you want it to be positive or negative. So let's say, right now, let's follow your book first. Now, let's say we bring a charged rod. The charged rod could be like just now that perspex, that thing that we rub, make it become positive. So what happens is now this plastic rod or perspex rod is positive. Doesn't matter what material, we just think of it as this is a charged rod. That means this rod already got charged. I write nicer a bit, so ugly the writing. Charged rod. Okay, we bring the charged rod near the sphere. All right. So what happens is when we bring it near the sphere, remember, this is positive charge. Now try to remember which one will the positive attract? Will it attract positive or will it attract negative?
Negative.
Okay, so which means because it attracts negative, then the electrons, I told you, is moving all over the surface of the sphere. Okay, imagine the electron all over the surface. Now what happens is because you bring the positive nearby, all the electron, the positive is there, they get very excited. Then they will go decide, trying to go near the positive because it's attracting but it cannot jump through the air. It doesn't have that energy to jump through the air. So just go really near, but stuck at the surface. The negative is all here. So when the negative charges move to this side no more negative, this side become more positive charge. Because the electron all go there already, At first the negative is spread out. So overall neutral, because all same. But suddenly one side, the negative all go that side. Here no more negative. Lost and negative become positive. Neutral, lost and negative also become positive. So that's why here we put that positive. It's not the positive go there, not the positive go there. It's here because got less electron, right? Okay, so then how to, so the first diagram, I write down for you what happened. In the first diagram, what happens is the positive charges in the rod will attract the negative charges. Wait, I put smaller a bit, otherwise I got no space to write. A bit. Okay. Then you can explain that the negative charges move towards the upper part of the sphere, then you can say that so the bottom part has less electrons, therefore it is more positive. Okay, so this is just to explain what is happening over here and make it bigger a bit so you can see. Okay, now after you do this, you take away the charge rod, the negative will spread out all over again, like nothing happened like that. So that's why the second diagram we see is someone put the finger there. Why? The purpose of the finger is so that, let me draw a second diagram. When you put your finger there, the charge rod must still be there, you know. You cannot remove it. It must still be there. Why? Because you need to maintain the electrons this side. But then what happens is when we put our finger touching the sphere, it's the finger, okay? So this is the finger touching. The finger, because what happens is you must remember the human body can also conduct electricity, but if a small amount then spread through, small amount flow through the body is okay one. It doesn't kill us, okay? It's just that, you know, you just remember that the human body are conductors. So what happens is, remember that I told you that the Earth likes to have electrons, right? But not only electrons go down to Earth, even from Earth they can supply electrons. So what happens is this: when your finger touch the sphere, the electrons are trying to go towards the positive charge, So from Earth, we are touching, so the electron flow from Earth go through our body, through our finger, flow into the sphere. So the electrons will flow into the sphere. So as a result, right, the electrons will go in and start to fill up the ball. It will also neutralize the positive charge here to fill up. So then overall, it neutralizes. This part becomes neutral. When here got more positive charge, more positive charge. Then what happens is now this sphere has become negative charge. So let me write down for you. Electrons flow through the finger from Earth. The sphere becomes negative charge. Put a bit smaller for you so that it looks small. Nice. Okay, up to here can follow or not? Can okay. This one maybe need some time to think, because sometimes after class a lot of my students always say they understand teacher explain. After class they look back, what, forgot everything the teacher said. So what I will do for you is I will also write out the steps. So you see, right, this is very important. Let me create another diagram for you. Diagram pula, see wrong thing. Start another slide for you. So the process to charge, and why I'm spending so much time on this also is because, like I said, it's always come out in IGCSE. First process is you must bring the charged rod near the sphere. Then secondly, what happens is, then you must touch the finger to the sphere. Okay. Then after that, remove the finger from the sphere. Remove the rod. Okay. Okay. So this is the process. Now, so step one, bring the charge rod near the sphere. So your book already did this. This is step one. You bring the rod near the sphere. Step two, touch the finger on the sphere. Number 3, number 4 is not here lah. But number 3 and number 4 are important because the sequence. Do you take away your finger first or do you take away the rod first? It's important, you know, because if you take the wrong one away first, then end up you didn't get the charge. You see, why we remove the finger from the sphere first? Because, let me see. Okay, because what happens is, step number 2. Okay, step number 3, right? Let me do this. I can't cannot copy multiple objects. Wait. I know there's a faster way to do this. I just my last one. Okay, you see, because let's say this is number 3, step number 3, and this is important because sometimes I saw this before they asked in past year question. Let's say, right, you now in number 2 just now, this was not the plus, right, and then this was the finger. Okay, so this is the finger touching. Okay, so what happens is if you take away the rod first, let's say the finger is still touching the sphere. Now the sphere we know is negative charge. If you take away the rod first, the moment you take the rod away, what happens, and your finger is still touching, if your finger is still touching the sphere, right? Now what happens is, no more positive, you know what happens to the electron? The electron will all start to go around. Why so much negative? Too much negative. It will then flow into the earth, go back to the earth, and then become neutral again. Then suddenly you got no more negative charge. Then you take out your finger, you check the rod is still, the sphere is still neutral. Then I did all that thing, how come it's not charged anymore? So that's why you cannot remove the rod first. You cannot, because if you remove the rod, your finger is still touching, it's still connected to the earth, the electrons will flow out straight away. It's very fast, not to say that, take out straight away. The electron can move so fast, you don't even realize that it's flowing, all right? So that's why you have to make sure you don't remove the finger first if you want to charge the sphere. So again, if you remove the rod first, the electron will move back to earth so fast it becomes neutral again. So wasted all the effort. So if you remove the finger first, why does that work then? Because if this is already the positively charged rod, now we already know the sphere becomes negative charge. So that's why you see your book, only the top part negative, the bottom part, they didn't draw negative because the bottom part actually neutralized already. The electrons will flow in, it will neutralize the bottom part. So overall become negative, right? And then what happens is if you remove your finger, suddenly, no more electron, the electron cannot go in and go out anymore. Now got excess electron, extra electron. After that, when you remove the rod, what happens is the rod no more already, right? Then the electrons will be like, no more positive, then it will start to go all over the place, start to spread out through the sphere again, but it can't go anywhere because the finger not there already, so the electron cannot go in, cannot go out. Now it's spread out all over the place, it becomes negatively charged. That's why you must remove the finger first. Can follow?
Okay.
Can, Okay. If you want to charge the sphere positive instead of negative, you do the same thing. There is no difference. This process that I write here is the same process, whether you want to make it positive or negative. This one, by the way, when you touch the finger to the sphere, it has to be for a few minutes. It's not you just touch few seconds and then okay. Few minutes, because you need some time for the electrons to flow in, enough electrons to flow. Even though I said electron flow very fast, but give some time so that more and more can flow in. Okay, so I'll just explain to you how now this is to charge it negative, but if you make it positive, then how come it can be the same process? Because I show you here. Now let's say we want to make it positive. So let me just type it up here. Now let's say purpose is to charge the sphere with positive charge. Now, it's the same process. It doesn't change, doesn't matter. So I'll draw it a bit smaller. I don't need to draw so big. Okay. So let's say here's the sphere. And remember, it must be on an insulated stand. If it's sitting on metal stand, also cannot, because the electron can flow through the metal. Okay. So this time, if you want to charge it with a positive charge, that means you bring the rod nearby. The rod must be negative charge, must be opposite charge. So you bring it. So you have to charge with the opposite charge. So this is a charge rod. So what happens now is the negative will push the electron go the other side, repel, so not the positive go near, it's just that now the electron go the other side, so this side become more positive. So this is step 1. So then step 2, what you do, exactly the same thing as with the other one, you must touch the finger first to the sphere. So in this case, when you touch the finger to the sphere, the electrons are now going to flow into Earth, not from Earth. So when you touch your finger to the sphere, this is a finger. This finger, okay. Sorry, my drawing not very good. So what happens is, here's your negative rod. Now, when you touch your finger to the sphere, the electrons, a.k.a. come, let's run away from the negative. I don't want to go near the negative. So the electrons will start to flow now, go into Earth. Electrons flow to Earth. So when they flow to Earth, that means now here, the positive, right? The electrons are all flowing out, the electrons all flow out. The electrons all flowing out, okay? So all negative charge all going out. So you touch for a few minutes, let the electrons go out. After that, you must remove the finger first. So you remove the finger. But the rod must still be there. Leave the rod there first. Don't take out the rod. Remove the finger first. Because once you remove the finger, the rod is still there. Then the electrons, no new electrons can come in. Suddenly here, not enough electrons, or the electrons all run away already, all go to Earth already. Suddenly, now this is positive charge. Nothing all floating outside. Okay, so no more. Then after that, when you take away the rod, let me draw here. Then when you take away the rod, then the memang is now all positive charge. Malas lah. I do this. Okay, so now number 4 is just positive charge. You take away the rod, it's now positive charge. Okay, so you need, maybe you will need some time to get used to the idea. Like now, I think you see, okay, can follow, but you need to learn how to answer the questions using your own words. Because like I said, this one is, they always ask this in exam. Okay, but up to this point, any questions or not? No. Okay, so I know that there's still some more things on page 173. Okay. Yeah, I also want you to do some questions, but I want to see how well you can answer the questions on your own. Okay, I will finish the explanation on page 173. Then I want you to do the questions and submit to me. Yeah, just to see whether you can answer or not. So I just go through a little bit more on page 173. You see, unit of charge. This one is quite simple basically. You can, so the unit of charge, coulomb, is just basically the unit for the charge because charge, positive, negative, you can also measure how much charge it carries. It's physical quantity. It can be measured, and that's measured in coulomb. The next part about electrostatic charge is just explaining to you the use of of knowing how the electrostatic charge works. Like the electrostatic precipitator is just used to remove bits of ash from the waste gas. That means, I just briefly explained to you. So how it works is, okay, so we have the electrostatic precipitator, right? That means, if you have gas like from the industries, in the gas, when before they release the gas to the environment, problem is the gas sometimes got a lot of dust and a lot of ash. So when the gas flows to go out, what happens is, oh, too much ash, too much dust. So they have the rods here, okay, that is charged. So what happens is it will charge it will produce some charges, right? Then all the charges released here, the particles will be attracted towards all the charges, becomes heavy, and then once it gets attracted to the charges, it becomes heavy enough, they will start to fall down. So what happens is then only the gas is emitted out. So this part is gas only. This one is gas with the ash and dust. So it's like ions. Imagine the ions are being released. They got charged, so the ash is attracted to the particles, then become so heavy they fall down. That's what it means by an electrostatic precipitator. Precipitate means to make it like like you know in chemistry precipitate is basically the solid inside the solution. In this case, the precipitate means something that's like a solid that will sink to the bottom of the container. Okay, photocopier. This one, right, photocopier, you can refer to your book. The book already mentioned very clearly. But how the photocopier works is basically, they have the paper, the plate, which is inside the photocopier, is a black color plate. They will charge, negative charge. So what happens is when the photocopier scans the paper, it gets an image, right? The image is transferred to the plate. How? It will shine the light onto the paper, shine the light onto the plate. The paper where it scans, where is white color, it will be the bright light. Where is black color, like the words, like the words on the book, right? There'll be no light. So this one they just put H because Miss Poma, right? So H. So anyway, so they will transfer the image onto the plate. So where the light shine, there will be no more charge. Where the light didn't shine, it will still be charged. Then thirdly, now here got charge, right? So then they will put the black color toner powder, because the ink is actually black color toner powder. So they put the black color powder onto the plate. But because only this part got charged, then only this part, the black powder will stick. Where there's no charge, the black powder won't stick. So it's like they pour, after that it will shake, then only the black color powder, right, is stuck to the negatively charged areas. Then they transfer the paper, they transfer the powder onto the paper. How? They take a piece of paper and they stick it onto the plate. So this is the paper, they stick onto the plate. Okay, so they stick the paper onto the plate. And then they will take out the paper. Now got the powder stuck to the paper. So the paper, right, you see, now got the edge stuck there. Okay, and then they will heat up the paper. That's why sometimes after you take the photocopy, paper is hot, because the paper, right, after you got the powder, to make sure that the powder stick to the paper, they will heat up so that the powder melt and stuck to the paper. If you don't have the heat, then you touch, you still see a black color on your finger. Okay, anyway, it's all written here already. Any questions?
No.
No. Okay, here is, oh, now only got 1 minute left on the Zoom. Here's what I want all of you to do. The questions on page 173, can you see your Q1, 2, 3 there? Can all of you do the questions and submit to me? That means you get on your paper or you get your book lah, you write down the answer for question 1, 2, 3. If you don't know, at least you try, you submit your answers. I just want to see what you know and what you don't know. I want you to try without me giving you the answer, because if I give you the answer, I don't know whether you actually understand and you know how to do it.